So for this example, we are going to be determining the point of intersection of two linear equations that sit on the same coordinate plane. And the idea is if we have two lines, the only way the two lines would never cross each other is if they're parallel lines. And parallel lines have the same slope but different y-intercepts. But other than that, if they're not parallel lines, the two lines are going to intersect at some point. So if we have two lines sitting on a coordinate system, the point of intersection that occurs is where the two lines are equal to each other. And that's exactly what we're going to do for these examples here, A and B. We're going to make these linear equations equal to each other, and where they're equal to each other is where they crisscross at the same point. So we'll do that. So for A here, we have the linear equation y is equal to negative 1/2 x plus 1. And then we have y is equal to 5/2 x minus 17. And again, we just make these two expressions equal to each other. So we'll take negative 1/2 x plus 1, and we'll make it equal to 5/2 x minus 17. And we'll just use some simple algebra and solve for the x coordinate. So if I subtract 1 from either side and then subtract 5/2 x from either side, we'll have negative 5/2 x minus 1/2 x, and that's going to be equal to negative 17 minus 1. Negative 5/2 x minus 1/2 x, that's going to be negative 6/2 x. Negative 17 minus 1, that's negative 18. Negative 6/2 is the same as negative 3x. That's equal to negative 18. Then we could divide either side by negative 3. Therefore, x is equal to 6. So the x coordinate will be at 6. So then we could take this coordinate 6 and we could slug it into either one of these linear equations. It doesn't matter which one, you just choose one and then solve for y. So how about if we just choose this one? So we have y is equal to negative 1/2 x, and what's x? We found it to be 6 plus 1. Y is equal to negative 6/2 plus 1. Negative 6/2, that's the same as negative 3 plus 1. So therefore y has got to be equal to negative 2. So for these two lines on the same coordinate system, they're going to crisscross at the point 6 and negative 2. Or in other words, this point satisfies both of these linear equations. And we could go ahead and check that. Let's give that a go. So we have y is equal to negative 1/2 x plus 1. Here is a negative 2 for y. So negative 2. That's equal to negative 1/2 x, and x is 6. Plus 1. Negative 2, that's going to be equal to negative 6/2. Plus 1. Negative 2 is equal to, this is negative 3. Plus 1, and of course, negative 2 is equal to negative 2. So it satisfies this linear equation. It's going to do the same for this one, so let's check it out. We have negative 2, that's y. That's equal to 5/2 x, which is 6, minus 17. Negative 2, that's equal to 5/2 times 6, that's 30/2. Minus 17. This is negative 2, and 30/2 is 15. And of course, 15 minus 17, that's negative 2. So it works for both, and that will be the only point that will work for both, because that's the only point that they could intersect being linear equations. So the same thing for B. So let's try B. So here we have the linear equation y is equal to 2x plus 4 and x is equal to 5. So this is a vertical line. And of course, there is no y coordinate. So what that means is if we have something like y is equal to 2x plus 4, x is equal to 5, that's a vertical line. So the intersection will happen where x is equal to 5. We just have to find the y coordinate. So we simply take the value for x and slug it in here and solve for y. So we have y is equal to 2x and x is 5. Plus 4, so y is equal to 10 plus 4. And of course, y is equal to 14. So the intersection happens at 5 and 14. And there we go.